convolutional neural networks. You know, the thing that thinks this is a banana? If you have half a brain cell, you're probably gonna know that this video is gonna be about me making a convolutional neural network. These guys are made for image classification. But what actually is a convolutional neural network? As I stated previously, these guys are made for computer vision. The reason we would use a convolutional neural network over an artificial neural network is because of how the convolutional neural network actually works. Why am I saying convolutional neural network so many times? Well, it's because it's kind of fun to say. I mean, you try it. Say convolution 50 times and you'll never get bored of it. The thing with convolutional neural networks is that not all neurons are linked together. Some may go to others or others may not. This is actually intentional. An artificial neural network would work fine on images like MNIST-784, which is just a handwritten digit classifier, but a convolutional neural network for detecting complex images would actually be better because there are less computations to have to be run. And that's because not all neurons are linked together, which is why it's intentional. One last thing to know about convolutional neural networks is that they have this thing called filters, and all that really does is that it allows them to look at more complex features. Now, the way they work is interesting. So the first layer is used to identify basic features like curves or something like that. The second layer could be used to identify shapes. The third layer could be used to identify parts of an image. And the fourth layer is used to identify large pictures, which is how they learn, like the big picture. And surprisingly, this is actually how the human vision works. Or so this book I have says. But before we code, I have to choose a target. And that target will be the Fashion MNIST. We're going to start simple, but trust me, I'm going to get better later. For those of you who don't know, Fashion MNIST is 10,000 grayscale images of hoodies, pullovers, and just a bunch of clothes. And what my computer is going to do is that it's going to be taught to identify what each of them are. Let's build one. This is what I shall install. Let's look at my code. So, first we import TensorFlow and FuncTools. We have our default conv2D, basically the default 2D convolutional neural network, so that we don't have to type this and then add these all over again. So, first we here in this partial thing, we say that it is a convolutional network. Then we define our kernel size, which is basically the size of our filters, I believe, and then padding, activation, and kernel initializer. So now we have just preparing our data, and once we print this out, this is our result. Okay, so now we define our network. So first we define the input shape. So it's just grayscale, so we got 1, and it's a 28 by 28 pixel image. Now we define our layers. So this first layer is 64 filters, and by convention, the filters double every time we have a convolutional layer. So then we do some pooling, which just means that it's going to make the image slightly smaller. So it just resizes the image. More convolutional layers, pooling, flatten that all, and then we have our dense layers. So we have 128 neurons, activation ReLU, and all these. So we do that again, and we have a 50% dropout. So and now finally we have our softmax. So this is our output layer. So we have 10 that is gonna classify. So that is the 10 Fashion MNIST. Now we define our data. So we have our callback. So basically that just helps us for early stopping. Because it's going to help us make it so that we don't overfit our data. I chose a stochastic gradient descent, so here's my learning rate, and I added some momentum to it. So then I trained my model using the sparse categorical cross entropy, which is a loss function. My optimizer is just going to be this one right here. Stochastic gradient descent, and here's what it's gonna tell us as we're training. Anyway, fit our data, all that 30 epochs. So this makes it so that it'll go through the trainings. It's gonna go through all the training data 30 times, Then we have our batch size. So this is how many points of the data it's gonna look at. So I chose 64, and I made my validation set. I made 20% of my data validation. So here's my training, and we were able to make it so that we have 92% accuracy, which is actually not that bad. I wish I could go more in depth, but that would be a whole other video. But if this video gets enough likes, I'll make a video on artificial neural network. Now I'm gonna implement a real neural network, and that one is gonna be the ResNet 34. What's a ResNet? A neural network is always trying to best model some kind of function. But to do that, it needs to go through a bunch of layers. In a normal neural network, an input, x, will go through functions f of x1 to f of xn, and finally reach a target function h of x. But in a residual network, it may skip a few functions or layers, getting to the output faster, meaning the layers that it does take, f of x, will be h of x minus x. Kinda resembles a wide and deep network, but not really. Okay, I think it's time to implement one. Now let's look at my ResNet. Okay, here we go. So we begin by importing our model, all these nice little libraries. Then we got to import our TensorFlow and FashionMNIST just so we can, kind of create the training set and all that. Now here's when we start to get a little different. We create our ResNet block. So here it is. Here's the sequence here with our this is basically what we're gonna put into our in total model. So that we create our block, our ResNet. Then we create our actual model, and this is similar to PyTorch, where you use classes to create your model. So yep, here it is. Here's our first convolutional network, and here is our ResNet blocks, and here is our total sequential model. Alright, so we got all this, we're good. Alright, now we have our model, and we're going to set that to our ResNet model. And we choose our optimizer, stochastic gradient descent, and we'll just do the same things we did last time. Alright, well, thank you for watching. Honestly, this was actually a really fun video to make, but it took me a while. So now that I've showed you how to instruct a robot, let me instruct you. Press get out of the full screen tab, and then you see that thing that says subscribe. Yeah, press that, and then press that button that says like. Yeah, there we go. All right, thank you, bye.